In this next chart, this comes right off the unit circle. I'm not going to actually do the chart with you, just like I haven't done some of the other charts. So I'm just going to write down unit circle. I'm going to fill in a couple things because I want you to know what's going on with that stuff. But then after that, I'm going to kind of leave you to fill out this chart for practice, because that'll help you understand the unit circle. So the sign. Remember, we talked about X and Y stuff. And now we use trig names, sines and cosines. So the sign is really the same as the Y value. And the cosine is really the same as X. Which means that the tangent has to be Y over X. And the cotangent would be X over Y. And the secant is 1 over X. And the cosecant is 1 over Y. Bless you. So that's kind of the big idea. So now, like, as I'm doing, maybe we'll fill out this chart. Grab your unit circles. Look at pi over 2. Pi over 2 is the same as blank degrees. 90. Oh. So at 90 degrees, the coordinates are 0 and 1. 0, 1. I don't know why they didn't list the x first and the y second. That seems ridiculous to me, but whatever. If I wanted the tangent, 1 over 0, undefined. Or I would even accept infinite, I guess. Because you can't divide by 0, that's an issue. But 0 divided by 1 is the same as 0. And 1 over the x is the same as undefined again. And 1 over the y is the same as 1. Because it's 1 divided by 1.
Oh, sorry.
Look at pi. Jennifer, are you asking a question or just stretching? All right. Look at pi. The coordinates are -1 and 0. You see that? Mm-hmm. So here's -1 for the x. Here's 0 for the y. The y divided by the x, or in other words, 0 divided by -1 is 0. The other way around, -1 divided by 0, undefined. 1 divided by -1, -1. And 1 divided by 0, undefined. Notice how in every single row there are 2 1s, 2 zeros, and 2 undefineds? Notice that? Because everything's 0 and 1. Next, let's look at 3 pi over 2. The coordinates are 0 for the x and -1 for the y. Y divided by x, undefined. X divided by y, 0. 1 divided by 0, undefined. And 1 divided by -1, -1. And then the last row talks about 2 pi or 0, I guess radians, either one. And that has coordinates of 1, 0. So the y, which is 0 divided by 1, is 0. The 1 divided by 0 is undefined. 1 divided by 1 is 1. And if you had to guess on the last one, you would guess undefined, because we need one of those. I want you to remember to write this down. Do it right now. When we talk about x's and y's, you should know that that also is referring to the cosines of the angles and the sines of the angles. Or in other words, when you write this down, x is the same thing as cosine, and y is the same thing as sine when we're referring to the unit circle. Okay, you know how when we did the hand trick, everything was positive, like root 3 over 2, 1/2, root 3 over 2, root 2 over 2, root 2 over 2, that kind of stuff? That's because the hand only refers to something called the reference angle. The reference angle is an angle between 0 and 90 degrees. And It has its terminal side somewhere in the first quadrant. It's an acute angle, which means it's between 0 and 90 degrees, and its other side is on the horizontal axis. So if I'm looking, and it's a lot of words, but basically what it's saying is, whatever angle that they give you, you can talk about it as an angle like this in the first quadrant. That's what they're talking about. So you're going to come up with a number, or a radian measure, degree or radian measure, that's somewhere between 0 and 90, or 0 and pi over 2. That's the whole idea. Okay? So let me show you how you do this. Let's say I'm talking about the angle measurement of 130 degrees. So here I am. I draw a 130 degree angle. I look over here, and 130 degrees is right there. That's my 130 degree angle. How big is this angle? This is 130 right here. Let's try that again. If this is my 130 degree angle, how big is the angle between there and the x-axis? This angle right here. 50 degrees. 50 degrees is the answer to my reference angle. That is the reference angle. What quadrant was I in for the angle that they gave me?
2.
Seriously, like, what is going on with my drawing here? Sorry, this is just bugging me. I was in quadrant 2. So if I'm in quadrant 2, there's a rule. The rule in quadrant 2 is you're going to take whatever angle they gave you and subtract from 180. Or in other words, the way that you got 50 degrees is that you took 180 minus 130, and that's how you came up with the reference angle. So this is the reference angle. 50 is the answer. How'd you get it? 180 minus the angle they gave you. Let's look at the next one. 210. (210 degrees) goes like this. 90, 180, 210. So here's 210 degrees. Comes to this point right here. And the reference angle is the angle always between where your terminal side is and the x-axis. Or in other words, inside of here. So this reference angle is 30 degrees. It's always between the terminal side and the x-axis. Terminal side, x-axis, monkey in the middle. Okay, don't forget that. That's really important. Oh man, what quadrant was that
3.
angle in? It was in quadrant 3. So the rule in quadrant 3 is you take your angle and you subtract off 180. So 210 minus 180 is the 30 I came up with. Now I don't really memorize these rules. I'm writing them down as I go because my brain doesn't hold that stuff anymore. I just kind of know where the angle is and I look at what they give me and I figure it out. But that is what the rule is. Last one in the degree measurements. If I draw this one, 315 degrees means I start at the x-axis, I swing around, and I end at 315, which means I'm ending with my terminal side in quadrant 4. So the reference angle is in between my terminal side, that gray line segment, and the x-axis, or in other words, inside of here. How big is that angle inside of there? 45 degrees inside of here. So my angles are always in between the x-axis and the terminal side. And there's got to be a rule, just like the other ones. So if I'm looking for my rule, the rule here, if I'm in quadrant 4, is? Excellent. 360 minus the angle that they give you. So these next three, the only difference is they're in radians. That's it. So as I look at the picture, because I know that you've all memorized your unit circle, 4 pi over 3 is in quadrant
3.
3 is correct. So here's 4 pi over 3. I don't even know exactly where it is, but this is my angle. Here's my terminal side.
Third of the way.
Okay, whatever. Who cares? It's just a visual. I just want to know I was in quadrant 3. Oh, hey! The rule in quadrant 3 from up above was the angle minus 180. But we're in degrees, so we're going to minus off pi. Very good again. And we're going to minus off pi. So now in quadrant 3, if you're in radians, you just say the angle minus pi. So 4 pi over 3 minus pi is pi over 3. Four pi over 3 minus pi is pi over 3. You need a common denominator, you can do that on your own. Next one. Uh-oh. 4 pi over 5. Do we ever talk about pi over 5s on our unit circle? No. Nope, doesn't matter. So in this next one, 4 pi over 5 is 4/5 of the way to pi. Here's halfway to pi, right? Pi over 2 is the y-axis. The x-axis on the left side is pi. 4/5 of the way to pi is in between those somewhere. So this is 4/5 of a pi, or 4 pi over 5. Here's my terminal side. What quadrant am I in? 2. In quadrant 2, the rule was take 180 minus my angle. I don't want to use 180, I want to use pi. So take pi minus your angle. And in this case, if you take pi minus your angle, 1 pi minus 4/5 of a pi would be 1/5 of a pi. 5/5 minus 4/5 is 1/5. Or in other words, pi over 5. It's about getting common denominators. And then the last one in radians is 11 pi over 6. And if you know your unit circle, you know that 11 pi over 6 is over in the 4th quadrant. So this is 11 pi over 6, or 11/6 of a pi. In quadrant 4, the rule was 360 minus our angle, but now we're going to say 2 pi. So in quadrant 4, it's now 2 pi, good job, minus our angle. Because here's our terminal side. We're almost to the 2 pi, but not quite. So 2 pi minus 11 pi over 6 is just pi over 6. So all of these answers that we're getting, the pi over 3, the pi over 5, and the pi over 6, are referring to an angle that we would be seeing in quadrant 1. That's why it's called a reference angle. It's something between 0 and 90 degrees, or 0 and pi over 2.